Thanks, James. I'm not that much of a boomer. Anyways, we can get started anyway. Has anybody had a look at the gears section for the JDR report yet? Found any problems? Or did Paul give you any mistakes in this chapter? Anything at all?
Nothing given.
Yeah, the pulley ratio is that
Mhm.
it's different from the specifications. Which one do we follow?
What are you reading off?
Okay, so you know how it says there that the pulley ratio is like 3-1 from A to B.
Mm-hmm. Yep. So what's the mistake there?
Oh, sorry, I'm muted. Doesn't that mean that A is 3 times bigger than B?
Yeah, that's right.
Which
That's
means
the
that
first
A.
mistake. So
Yeah. So
what you
what?
pick, like, it's not a mistake in what we're asking you. It's a mistake in the report itself. So it says 3-1, but he calculates A to be
1.
3 times 835, but that's
But
wrong.
isn't it?
It's
Yeah.
it's supposed to be 835 divided by 3.
Yeah.
So I can't see the preview for my camera. There you go. So it should actually be A3 835, which is what, 27 something, I think.
Yeah. But do we follow the? So we follow the specifications, right? Not
Yep.
the 1 to 3 that he calculated.
Yep, that's right. So that's your first critique in the gear section.
Also, the 75 kilowatt power that he gave is also wrong. So do we not follow that too? In all our calculations, do we use the 400 horsepower
So
power?
if you read the assignment, it in part B part 2 where it tells you to redesign, we give you another motor to use. So you don't have to use that at all.
But then for calculating, because if you need to calculate like further down, he calculates the the torque, right? But he
Yeah.
based it off the 75 kilowatt power, or was it no? He calculated the tangential forces
Yep.
based off the 75 kilowatt power. So do we use 75 or do we use 298?
You would use 75.
But it's wrong, right? No, right.
Yeah, it's wrong.
But we still use it.
Yeah, you do. Because what you're doing is you're critiquing his calculations based on what his setup,
Okay, yeah, that's what I was confused
not what
about.
the
So
motor's supposed to be.
okay, so then everything that follows from that, like the bending stress thing that we did last week, we have to
Yep.
use 75 kilowatts for that too.
Yep.
Okay, cool, thanks.
Any other major problems? Compare that with your Martin Gear catalog as well. Check the horsepower and the speed ratings for those two. What else? Torque. Yeah, just redo that calc, see if it's right or not. And I won't give you any more. That should be easy enough. Was this week's lecture live or was it recorded? Yeah. Okay, cool. Because I got an email saying that like a lecture was uploaded. What was that about? Just an additional one. It doesn't really matter anyway. All right, this week we're going to be comparing and evaluating belt materials based on our setup. What's the point of that? Doesn't it double up? I mean, is there anybody who watched the recording and went live? Oh, okay. That's useful, isn't it? That's pretty good. It's more than what Nick's doing. I keep on saying that I'll go to both and uh, like come in and evaluate it and see what's good or not, but I keep on forgetting. Do I have to zoom in with my camera or not? I found this um, I found this Android app which lets me use my phone as a webcam, and I might have pirated it. Is that better than last week? Cool. So I don't have to record it or scan my notes and put it online. That's what I'm gonna take it as. All right, let's go. Step one. To start off with the evaluation, you've got to find some properties about the pulley system. Now they're huge. They're like overhead cameras. I mean, I probably could. I could just say that I'm borrowing it to security when they ask me what's going on. But I can't fit that on my desk. All right, contact angle. There's two situations. There's one with this open put and belt. And for this situation, you've got a smaller OD, smaller D, and there is a larger one. Oops, I should write contact angle. So the contact angle would be there to there, and there to there. Smaller, larger, duh. And there's also, oops, and that's when you have the pulley belts crossed. And the contact angles between the smaller and the larger are actually equal. The main differences between the two are that these pulleys are going to be rotating in the same direction as opposed to uh, it's going to be reversed. Depending on which direction you want your system to go in, that's what you decide. And also, most of the time, your contact angles are going to be larger with the closed belt system. So larger contact angles, which results in more friction and less slippage, which I would prefer most of the time. 2. Centrifugal stresses. Oops. And that's calculated as T equals P. Oh, no, that's the next one. FC So that's just weight divided by gravity. That's in forces times v squared. And that's just the forces acting upon the belt. You can also call that hoop stress. So more hoop stress equals less less grip, because the forces are going to be acting outwards, decreasing your grip. 3. Torque. Oh, just a note. There's going to be different formulas for each of these, and they're on your lecture slides. So make sure you read the question properly in, I think, next week's quiz, so you won't stuff up. T P times KS times NFS and P's power. KS is like an operating factor, service factor. And that's going to be given. And NFS, safety factor. That's usually decided by you or given, depending on where you work. And N is angular velocity. Sweet. 4, transmitted load. That's the forces you're introducing to the belt system through whatever's driving it. F equals 2T on D. D is going to be your smaller diameter. I'll throw this in too. Difference between F or transmitted load is also your tight side tension and your slack side. Yeah. Cool. Next. Is everyone done with that? Five. Allowable tension. More formulas. So that's the F1A from the previous formula. B times FA times CP times CV. B is going to be your width. It's in meters. FA allowable unit strength. Be careful with this. In the tutorial sheet, it says it's kilonewtons, the unit is actually kilonewtons per meter. So make sure you write that down, or else everything's gonna blow up after. CP, CV, correction, and velocity factor. These are all going to be given, depending on what material you choose. 6. Slack side tension. It's pretty much your transmitted load minus your allowable tension, which is what you just calculated. So from 4. So F2 equals F1A minus delta F, which is number 4's formula. Or you can simplify that as 2T on D. Seven. F1 initial tension. And FC is your centrifugal or hip stress. I think that's number 2. And it all comes together 8. Friction. Yeah. So you just gotta check that your friction doesn't go over the allowable limit of your material, or else it'll slip. Nine NFS. That's your factor of safety. PA, P norm. We're gonna deal with all of that later. Cool. So we should start with evaluating your materials. So at the end of the tutorial, I added in your data just to neatly wrap it up. And there is a list of basic polymer materials that you can use for your build system. We're not going to go to like leather or anything like that yet, because all this data is here for us that we can use. So,
Sorry, could you get back? I want to get some screenshots of 7. All right, cheers.
all right, given data. Okay, power, or we wrote as P. It'll be 75 watts. Size ratio. So 1 to 3 is 3. Factor of safety. 1.2, I think. One point five. A speed. B speed. 275. Yep. 825.
Sorry. Do you just pick a poly FO just because it's just a guess and they're just checking that, or is there a reason? Can't hear you if you're talking.
Hello.
Yeah, I can hear you now.
Hi. All right. What did I say? I said we're just gonna do F0 first, and then after we're gonna do all the others too.
Okay. So
It doesn't really matter. Like I've got the answers for all of them. But you're gonna have to evaluate all of them for your assignments anyway. Okay. What's that doing? All right. So step one from what we wanted to do. So this is the step-by-step process of how you want to do it. I'm just gonna write down all the formulas. So contact angle. Oh no. Sorry. F0. So the figures we have is T, D. So we want to write down what we do have. A specific weight. Yep. We have coefficient of friction, or depending on how you write it, CP. We have large D as well. And distance between centers. That's from our JDR. All right, contact angle. Theta D, oh, smaller, is pi minus 2 sine D 2C. Be careful with your units. That's going to be in radians. So when you calculate that, it's definitely in radians. And then theta greater D, pi should be plus 2 sine. Yep, plus 2 sine D 2C. And we've got all these values. So we're sweet with that. So one's done. Two. So we wrote that as Fc equals weight on gravity v squared. And the formula for weight depends on identity, unit length times thickness times b, which is your width. But we don't have width until the end. So we can collate this as A. And I'm just grouping that so we can sort it out later. So rewriting FC with that grouping, I'm writing A1G times, oops, that should be a times, B squared times B. Or that can be B, oh, A2. So rewriting that, A2 on B. Sweet.
So in these brackets for A1, is it gamma times T times L, or is that plus?
Yep. Oh, that's a times. That's a wonky plus.
Sweet.
So just so we don't forget, 1, 2, 3. We're all gonna bring it all together afterwards. Revisiting talk, which was 3. Torque is P times Ks times NFS on that. And we've got all these values, so we don't have to simplify anything. 1, 2, 3, 4. 4. And then next would be transmitted load. Transmitted load delta F equals 2T on D. If we have all the answers for torque, we can just shove that into that. So we've got that. 5 allowable tension. FA CP CV times B. And the only variable in this equation that we don't have is B. So we're going to cut that out again. A3. So F1A A3 times B. That'll be a 6. Yep. 6. Slack side. Just a quick question. If this is our driving pulley, so the force is starting from there, which side would be your tension side? Which one would be your slack side?
Top will
Any
be in
guesses?
tension.
Pardon?
The top will be in tension and the bottom will be in slack.
Cool. 1, 2. So if you're doing a pulley system, where would you want your slack side to be? Any guesses? Would you want it to be on the top side or the lower side? If you could choose. Ooh. Yeah, the top is tension, but why would you want the tension to be on top rather than at the bottom? Jeez. I'm gonna ignore that answer. But the thing is, you actually want the slack side to be, ooh, tension on the bottom to compensate. Compensate what? I can't tell you too much about pulling out. I don't do that. Well, the thing is, you don't actually want the slack side to be at the bottom because it sags down. If you wanted to design this better, you would have the slack side on the top, because if you do something like this, you actually get more contact angle. But if you have that, it'll sag like that, and you're gonna lower. You see what I did there? So keep that in mind when you're reviewing the pulley section in the JDR report, which you're going to do this week, and not forget about it. Right? That's just a little hint to you. Slack side tension. Bring it back. Sorry if I offended anyone. I think that was too far. Anyways, same with this. We don't have the B in this because that's going to be in there. So 7. What's TOS mean? Oh, I'll give you guys time to rewrite that. I didn't do anything. I just rewrote it. Next. Initial tension. F1A, F1, oops, sorry, that's Fi, F1A plus F2 on 2 minus FC. Nah, everyone here's like, everyone over here's 18. Sorry, at least 18. That's your next one. 8. Hasn't Twitch been like under lots of fire for being very sexist or something like that lately? Or the mods at least. Have they solved that yet? Because I don't really follow. Or is it still bad? F1A minus F2. F2 minus FC. Yeah, but what other good streaming platforms are there? YouTube equals 1 theta. So I'm just going to rewrite these in terms of the values that we don't have, and that's going to be F1A. We found it before to be, or we simplified it to be A3 times B. F2, I believe, was A2 on B. Over what? F2, we've got that in the previous, in number 6, I think. A3 B minus 2T on D. minus A2 times B. We've actually got all of these values except for B. So we want to move that to one side so we can calculate it.
So is
Algebraic
the
magic.
equation wrong on the top line? You have F1A minus F2, and then you have F2, but they equal two different things on the next line. You have like F2 on both like the top and bottom. Should be FC maybe.
You're right. Hold on. Yeah. Yeah, you're right. How'd you pick that up? Oh, it's because this isn't the same, right?
Yeah, because I wrote A2B and then you wrote something different.
Oh, yeah, that's right.
Yeah,
Yeah, that's
so
what my notes say as well. Yep, cool. Who was that?
me, Asher. Bonus box?
I'm gonna pick on you.
Oh shit. Haven't watched
All
that.
right. A2. A2, we simplified it as that. So A1 over G times V squared. So I'm only simplifying A as the values that we have. No, don't keep your mouth shut. I'm already picking on two people, Asher and this other student in Friday. I actually made a poll and asked everyone if she should be kicked out, and everyone said yes. That's funny. E F theta A3 times B A2B A3B minus A2B minus 2T on D. Did you hear about it on the MD2 Facebook page that I'm not allowed in? We're going to do some more algebraic magic. B A3 minus A2. Yep. No, the answers to that are wrong. I'll fix that up for you. Sorry, the next step is getting B to the other side and through some algebraic magic. E F theta A3 minus A2 E F theta minus 1. Yep. So just to save time, we don't have to go through this exactly how I got there. Because we've only got like 40 minutes left. Cool. Now we can finally start subbing in some numbers. So, where's my camera? So rewriting what we do have. Okay, solving for F0. Be careful with the units for this as well. Especially when converting kilonewtons, kilonewton meters, and like torque and all that. FA is 1.6 kilonewtons per meter. If you get stuck in your calc for your assignment because of your allowable tension, that's why it's wrong. 9.5 F is 0.5, that's your friction, unitless. CP, that's unitless as well. D, 15 millimeters. Wait, what? 45. Smaller, larger, millimeters, meters. And the way I got that is just timesing it by 3, which is your pulley ratio. And C is 1500. And that's from your JDR report. So now, find. What do you want me to upload? The video or the notes? Find T, find A3, A2, A1, and then your contact angles. The JDI answers, what a joke. Probably not, so just take screenshots. Why do you guys like uploaded notes so much? Back in my day, no one used to upload.
Too fast, bro. That's why.
Who said that? I'm kidding. No, I'm not fast. Just take screenshots. It's 2 buttons.
Can you record your voice as well?
Actually, Zoom records everything to the cloud, but I couldn't find it anywhere on my Zoom account. I don't know where it is. Nah, no Facecam. Nah. Well, if I upload the videos, half of it would just be you looking at the wrinkles on my hands, right? Do you want that? I don't think so. All right. Let's start off with some juicy calculations. Finally. That should be 1. C. Remember again, that's in radians. What am I missing? Yep. So pi 2 sine. And you should get around 3.12. Remember again, there's 3 different formulas for whichever pulley system you have. Cross versus open. That's an 2. Yeah. So 2. Would be your A1. (9.5) times 0.8 unit thickness, and then per unit length is just 1. That's just 1 meter. 7.6 Newton meters. Three. Oh, did you? How'd you get that? Is you calculate in radians? There you go. That's all right. That's what I'm here for. A2 is A1 divided by G times V squared. And V squared can also be written as, or simplified to this. So converting angular velocity to velocity should have all these values. 7.6. And what is specific gravity in Australia? 10? What's G? Eight two five 9.81. I've got 0.325 n.
Sorry, is N just the output RPM?
Yes.
Sweet.
Yeah, that's right. Yep. Next. Tension, which is number 4. T equals P Ks NFS divided by velocity, and converting that from 825 times 2 pi 60. Angular velocity from RPM. Make a note of that too. That's key. $75 kilowatts times. Oops, I should run 1.5 times 1.2. These two are given. Or you can vary that in your assignment if you want. So if you want something safer, you go for like 2 at least. Equals 1565.21. 5 times CP times CV 1600 times 1 times 0.95. That should be newtons per meter. Yep. Delta F 2T on D. Oops, I didn't find that out. That's the same unit as that. Shove that in. Two oh eight 348. That's a very high number.
The answer for
Very
A3 is wrong.
Pardon?
Answer for A3 is 1520. 1520.
Is that what it is? Did I use the wrong number?
Yeah, you used the previous answer.
1600 times 0.95. Hi, is my audio back? I'm actually using two headsets, and for some reason the second headset keeps turning off. The one with the better microphone. So I'm actually wearing two headsets right now. Yeah, I did. But this is me using T, which is 1565. A3 is still 1520. So those are two separate things. Sorry if that's not clear. To Rampton. So these are two different values. Stop calling me a boomer. Oof, please. A3, 1520 minus A2, 0.325 times E 0.5 times 312 minus 1. Is that clear enough for you to read?
So why do you use the small angle as well? Able to explain that?
The small angle rather than the larger angle.
Yeah, like why is it always small angle?
It's more likely to break it in the smaller gear than the large gear because
Ah.
there's less material. Good question. I'm going to attempt to do this on my ancient calculator. Mm. Sweet. Don't I need like more than just a microphone to use that? Don't I need like a DAC as well? Right, to bring it back, this is the width of the pulley that we need. If we're using poly F0, the width of the pulley has to be 173 meters. Let that sink in. Weight. So I'm just tying this back to the original workflow that we had before. So weight, hoop stress, allowable tension, yada, 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 which we summarized before. A1, we've got that 7.6 times 173.5 equals. So the weight, combined weight of the pulley is going to be 1300 newtons.
Now, is that just like the weight acting on the gear, or like the pulleys from the belt?
That's just the weight in total. So yes. So it's pretty fat, isn't it?
Yeah.
How to get that? 56.39, and that's going to be newtons too. Cool. Hope you were done with that. Allowable. F1A A3 times B 1520 times 173.99, which is a lot. Oh, 50, sorry. That's a lot of newtons. Slack side tension. I've got 55. Initial tension. F1, F1A, F2, 2, one, 5, 9, 3, 7, 3. So it's a fat belt. That is our analysis of the F0. If we wanted to use the F0 and have it hold up to our system, which is a 75 kilowatt motor, we would need the width of it to be 173.5 meters. That also means that your pulley, which attaches to that belt, so top view, let's say not to scale, obviously. That's just a rough top view drawing. That's B, pulley B, and pulley A. That has to be 173 meters long. Can you imagine how heavy that pulley would have to be if it was made of aluminium and 173 meters long? So does anybody think that F0 is a suitable choice for our system? Big no, huge no. So what do we have to do? If F0 is unsuitable, what do? We have to evaluate the others. Every single one, F1. And instead of going through all these manual calculations, how can you evaluate them all in one go?
Excel.
And here is one I prepared earlier. If I can get it up. There you go. I won't be uploading this, but I'll be uploading the numbers. So you can see that with the open belt system, you have to go all the way down to the A5 to get something that's remotely viable. And even then, like having a 30 centimeter thick pulley is still pretty ridiculous. Yep, it's definitely a chunker. So what can you do if, let's say, the manufacturer only supplies a 0.2 thick poly A5? Yep, and how could you do two belts? Like two belt systems? Yeah, you could do that. That works. There's no real wrong answers here. It's preference of how you want to do it. Ooh, a notched pulley. Two closed loop systems. Yeah, that works. Notch pulley. Yeah, that's heaps fancy. I like that. There's no wrong answers when you're critiquing this. So be creative when you write your solutions. Are there any other questions about pulley built systems? It's pretty straightforward, I think. I mean, like, they already give you the 3-to-1 ratio. If they didn't, that'd be a lot tougher. Don't forget your factor of safety as well. But I'm not going to do that. You guys can do that. Factor of safety and also your friction check. You can do that on your own time. All right. Quiz prep. I'm going to give you some stuff. It is next week, isn't it? Your quiz. Or starting next week.
Are the quizzes just like in class, or is it like ETS online? How's it run?
So last semester we had it online and it was open for a whole week.
Oh, sweet.
Yeah. So you should have 1 week. What do you mean no quiz? Do you mean that you don't want a quiz or there isn't a quiz? Okay. Yeah, there should be a quiz. Bloody hell. So normally what we did was we split it into 3 classes and had everyone come in class and do it over 1 hour. But obviously we can't because, you know, the coronas. But this semester we should be opening up for 1 week. So you have a 1 week window. But once you start the quiz, you only have 1 hour to finish it. So you can have like all your notes and stuff open. So it's pretty. No, 1 hour. 1 hour. Yeah, that's why I'm gonna make it harder this semester. Because everyone's gonna cheat. Okay. Your notes will be. Types of gears. So bevel gears, and your helical gears, know what they are, and know the differences between the two, advantages, disadvantages. Yeah, there's unlimited attempts. And if you need help with that, you just shoot me an email as well. Functions of gears. Why do we have gears? Now it's not so much cheating, it's just I just want to make it harder because I feel like it. Gear ratios. So I gave you the formula for gear ratios last week. So N in, N out, and what's the relationship between that and like speed in, speed out? SFS. I want to get a good SFS anyway. Everybody loves me. Process of choosing gears. So that's to do with the modern gear catalog. Gear properties. So gear properties as in like addendum, dedendum, gear speeds. That's pretty straightforward. Factors of safety. Be clear about the difference between bending and surface factor of safety. Friction. So friction in what's the use of friction in mechanical devices? Why do we use it? What else? What else can you use instead of friction? There's like V-belt and all that stuff. That's on your lecture slides. Coefficient of friction. There are additional materials on UTS Online in the friction week. So have a read through that and make sure that you understand everything about it. Contact angles, that's a big one. I think I mentioned this like 3 times. Remember which ones, like what are the differences between the 3? Winches, we don't go, did we do winches in the lecture slides from Paul? Anyone who won't? So like, if you had a winch and there's like how many times would you have to rotate a rope around a winch for it not to break? So in the recorded ones, it is in there. Your hint will be P on W. Off the top of my head, it's the total force is equal to 2T on D. I'll put a question on UTS Online as well. Yeah, I'll put in one question. So try and trying to understand how I got to that answer. It's definitely in there. I posted it up as an image file and power calculations. Everything should be online. And if you want to do some further reading, I'd recommend this. That. This is where we base most of the material from. So if you want to find out more about what we did, find that textbook.
Wait, so is it just one question, or are we going to be getting questions on each of these?
I can't tell you that. Prepare for everything.
There'll be like multiple choice questions and like short answers, or oh,
There's some that are going to be multiple choice and some will be calculations.
sweet. So one thing before you said when you talk about the contact angles, you're saying what are the difference between the 3? I thought there was only 2 contact angles. What's like the third one?
Yeah, well, there's only two there's only 2 formulas, but there's 3 cases. So like, I think it was the larger diameter, the larger contact angle for an open belt is the same as a closed belt. Does that make sense? Sort of.
Kinda. You go over it, make a diagram.
Okay. I'll go to the lecture slides. It should be there. Give me a sec. Okay. It is. Oh, I just had a bit of a moment. There. Okay. So have a look at what's written here. So for open belt systems, it's pi d equals, theta d equals pi minus blah, then d minus d. But for cross belt system, there's a plus there and a plus there.
Sweet.
Yeah. So if you're gonna do cheat sheets, have this whole page in there because it's got the 2 different formulas for the length of the belt as well. That's definitely useful.
And that diagram there, that's for the that's the open belt system.
Yeah, that's definitely open build system.
Yeah.
Yeah, the bloke who wrote this lecture material wasn't that clear about things. So it takes a bit of deciphering. Cool. What else can I give you guys? Oh, compound gears. I would recommend going to Google and looking in compound gear questions. The answers. No, everyone's gonna get like randomized questions anyway. So I can't give you all the answers. So like for question 1, I think there's 6 different questions, if that makes sense. So try and look up a compound gear question. So it'll ask you find 3 gears that'll make up a gear ratio of 1/20 or something like that. You should have went through this in the lecture as well. I'm just gonna reiterate that. Compound gears, there is one question on compound gears. And I think that's it. That's all I'll give you. Any questions?
So this quiz just it's available from next week's lecture or something, or
Yeah, I'll make sure that it's open after next week's lecture,
alright, sweet.
unless Pause wants it run in a different way.
And then it will last for 1 week, is it?
Yeah, you have one window because like some people are still overseas as well, so they can't be doing it at the same time that we do it. So we have a 1 week window to make it easier for everyone.
But we're definitely going to get a 1 week window. Wait, he won't just tell us like a couple days before tests on this day. We have to do it on this day. It's definitely going to be
Well,
one.
Well, are you guys timetabled in for a quiz slot? Alright, so it's 5 p.m.
Not that I know, but maybe.
Yep, okay, so 5 p.m. Tuesday, that's when I open it. And then you will have until like Tuesday 4:59 the next week. So it's 1 minute less than 7 days. Don't stress about the times too much. Just do it next week. It's next week. 18th of the 8th. Yeah, that's next Tuesday. Cool. Anything else? All right, if there's nothing else, thanks for coming. I'm gonna go soon. Any other pages you need me to come back on? My writing's pretty shit. Everything in this tutorial is pretty straightforward. Just prepare for your quizzes.
Thanks, Michael.
Yep, no worries.
Is that?
See ya.
Actually, can you please show me the first 2 pages? I missed screenshot.
Yep.